Welcome learners to the teleconferencing session on digital image and its characteristics. Today's session is based on the course MGY002 image remote sensing and image interpretation. This is from the program PGCGI, that is postgraduate certificate program in geoinformatics. So let us begin the session on digital image and its characteristics. So here in the slide you can see sir, please display the next slide. Please display the next slide. Here in this you can see this is an image, or this is a satellite of remote sensing image. This is a part of Gujarat where it's showing some objects like river, like sand, vegetation and habitation. So any remote sensing analyst this derives the information about these objects through image interpretation. So image is the base of extracting information about different themes, and this from these themes we can prepare some of the thematic maps. So now coming to today's session, the outline of this session is we will discuss about what is an image, then what is an digital image, then further we will discuss about types of images, image characteristics, and the overview of digital processing. Now what can be derived from a remote sensing image? You see informations about this biophysical variables like location, elevation, then characteristics like vegetation, water, soil, temperature. These are the information about this biophysical variables. Now, however, this information they need to be extracted from images. So, in the next slide, here you see this extraction information are from remote sensing data that requires the analyst that understands the characteristics of the data that being used, and the physics of how the electromagnetic this energy interacts with the phenomenon of interest, and also the correct application of image processing techniques to extract the information from this image. Now coming to what do you mean by an image? You see, image is nothing but this is a picture or a photograph, and this image, this is the convenient means of storing and conveying the transmitting information. This image also they convey information about the positions, about sizes and interrelationships between objects, and they portray spatial informations that we can recognize as objects. And thus an image is a summary of information of the objects that it represents. Here in this image you see this is an example of grayscale aerial photograph, where we can see in the this right hand side you can see rivers, we can see sands, and also we can see vegetation. In the next photograph here you can see this is an example of colored aerial photograph of a coastal area, where here also we can see from the color we can distinguish or we can identify this as sea, then sandy beach, then we can see this rivers, vegetation and habitation. And in the next slide you can see This is an example of a colored aerial photograph of an inland area where we can see agricultural fields, trees, and habitations. So, in these three examples where I have shown you the grayscale photograph, the colored photograph, what this image depicts, or what an image gives. This is gives the information of an images that are presented in tones and colors. So, photographs are images which are recorded on photographic films, and they have been converted into paper form by some chemical processing of the film. So, whereas an image is a pictorial representation, you see all photographs are images, but not all the images are photographs. So, this is all about an image. Now, coming to the definition of what is digital image. You see, digital image, when a paper photograph is scanned through an scanner or through a machine and they are stored in computer, it becomes an digital image. So, in digital mode, you see photographic informations is stored in an array of this discrete numbers. So, is each of the numbers that correspond to dots, or that is the dots we say as one image element. So, this image element is the smallest part of an image and is known as picture element or pixel or fel. So, in this slide, you can see these are the image, and these are the individual bands of satellite data in grayscale image. And these digital images are composed of some rows and columns of pixels. And these pixels have spatial references like geographic coordinates. So, after this, we will discuss about digitization. I will request Professor Desmukh to discuss about digitization and DIP processes.
Thank you. Learners, initially when we used to get images, we used to identify features from hard copy printouts. But now most of the images they are directly recorded as digital form and in the medias, and that is made available to the users. Now, the earlier when it used to be in the hard copy formats, and that used to be converted to a digital form through the process of digitization. So, before processing, before interpretation, it used to be processed or converted into a digital form before we actually apply image processing. As we know, the image is divided into horizontal lines, which are made up of adjacent pixels, and at each of the pixel location, the image brightness is sampled and quantized. We will learn about this a little bit here. So the process of this digitization, it generates an integer value at each of the pixels, representing the brightness or the darkness of the image at that particular point, and is represented by a two-dimensional integer array, and the brightness value is called either the gray level or the digital number or DN. So here it is a zoomed portion of an image wherein you can see these pixels are visible here, and you can see here this is a grayscale image. Here the darker pixels are represented by lower digital number. In the case of brighter pixels, which are having comparatively much higher pixel values here in this particular case. So here the range of values, which is now also known as the quantization level, it ranges for this data from 0 to 32, where the 0 represents the darkest or the black color, and the 32 represents brightest or the brightest or the maximum pixel value. Now, through this, now we can define image as a two-dimensional light intensity function fxy, where x and y are the spatial or plane coordinates, and the function xy is a value which is proportional to the brightness or the gray level of a particular feature or object in that image at that specific point or location, that is xy here. So a digital image is an image fxy that has been discretized both in terms of spatial coordinates and brightness. Now, as we know now that digital image is composed of a finite number of pixels. The number of pixels depend upon the how many rows and columns are there in that particular image, and each of the pixels has a particular location and the value, and the number of pixels, as we mentioned, an image depends upon the image size. So what is the length and width of the image? So depending upon that, the number of rows and the columns are defined. So in an image, in any image, bright areas are represented by higher values, whereas the darker areas are represented by lower values. And as we discussed earlier, these values are known as gray level or digital number, or in short it is known as DN value or DN. Now we were talking about the quantization level here. So depending upon at what quantization level the image has been digitized, the range of values will differ. So this table gives an idea about the different quantization levels. Here it is shown as bit number, and on the right column it is showing DN range. So the range of value, as you can see, as the bit increases, the quantization level increases, the range of values are increased. So we will again discuss about the quantization level at some other slide while discussing about the characteristics of images. Now this images, digital images are of four different types. One is the binary image, or it is also known as black and white image. Then the grayscale, or it is also known as monochrome image. Then the color, or the RGB image, and the last one, the fourth type, is the pseudo color. We'll discuss about each of this type one by one. So now coming to the binary image, you see here binary, it means that it has got two values, so 0 and 1 are the two values which are available to represent features in an image. So here the 0 value represents here the water, and the bright one, the 1 value, represents the land feature. So these are the two features which are present in this image that is represented here in the left side. On the right side, you can see here, this is an example of a grayscale image, and wherein there are some values in between 0 and 1. Here this is an example of an 8-bit data, so where the value ranges from 0 to 255. So there are a total of 256 values are available here, and you can see here, you can see the variation in the pixel values in the water pixels in this here. This is the third type, which is known as color image or the RGB image. Here you see in the previous two examples we saw that those are the individual bands. But in the case of color image or the RGB image, the three bands, any three bands are combined to display the image in color. So here this example is that it has 3 bands which are shown here. So the values for this particular pixel, this area, this small area, the values for these pixels in 3 different bands are shown in this. So here this is shown as a blue, green and red color. We will discuss about this color concept little later. But now coming to the fourth type, the pseudo color image. Now as we discussed, images contain information, and those information are extracted by image analyst, and the analyst prepares a thematic map. Now those thematic maps are generally in gray color, and the colors are assigned to different themes, different classes of a particular theme, to represent those classes in different colors for better visualization. So here are two different examples. One is a example of a ratio image, wherein some processing has been done on image, and then the values are represented in some colors. And on the lower side, lower right side, this is example of digital elevation model, where the elevation values have been given some colors. So here the lower values, lower elevation values represent blue color, whereas the higher elevation value represent the red color here. So this is how the elevation values are represented in this particular example. Now we are talking about color composite. So this is the first image that we saw initially when we began our session here. So here you see this is different features like as madam has mentioned, the river, the sand, habitation, and some vegetation are represented here in blue color. So this is the image as we generally see in different uh, Google Maps or say Bing Maps or Zoom Earth or like that. There are many platforms wherein we can visualize such images. So these are the images which are as if we are seeing things from our eyes. So like vegetation, they appear green to us. The leaves appear green to us due to the presence of chlorophyll. So that here also this features vegetation appears green here. But in the next slide, this is the same area, image of the same area, but different band combination has been used to visualize the image. So herein the different band combination I may utilize. So vegetation areas here appear in red color, whereas vegetation the water area is shown here in cyan and blue color, depending upon the concentration of the turbidity. And this is the sandy areas, and these are the some of the habitation areas are represented here. Now we have seen two different kinds of color composite here. So what is the logic behind the color variation in this? Let us see about that. We know that sun is the source of energy for remote sensing, and this is the entire spectrum, entire electromagnetic spectrum from gamma ray to radio waves, which are available. And in for the most part of the remote sensing, this is the portion that is from visible and infrared regions are utilized for remote sensing. So you see here, this is the small portion of the entire electromagnetic spectrum, where the red, green, and blue regions are available, in which generally remote sensing images are acquired. Now taking this concept further, you see that we know that images are acquired in different wavelength regions of this electromagnetic spectrum, and this computers have a limitation that we can see images, we can see only 3 images at a time in some combination, because computers have 3 color planes: red, green, and blue. And although an image satellite data may have an n number of bands, but at a time we can visualize only 3 bands. So any of those bands available for the images, they need to be placed in this color planes of the computer monitor, and accordingly those bands are visualized. Now in the case of true color composite, in this example is shown here, the image acquired in the blue wavelength are placed in the blue plane of the monitor, and image acquired in the green wavelength region are placed in the green plane, and the image acquired in the red wavelength region is placed in the red color plane of the computer. Then in that case, the image output will be as if we are seeing from our eyes. So this is it is called as true color composite. In the next example, it is shown here that if we have a number of bands, and instead of the red, green, and blue bands, we want to visualize some other bands. So in that case, any of the bands are chosen, and they are put in the red, green, and blue planes of the computer. In that case, we generate an image that could be not a true color composite, but it may be some other color composite. And because they are not true color, they are not showing true color, they are known as false color composites. So this is an example of that. On that, we have just seen here one band we have chosen, and then other bands have been placed in three different color planes, and that is how false color composite has been derived. So this is we have learned that we perceive colors using different sets of wavelengths, and there are three primary colors: red, green, and blue. So any color variation that we see in the image is due to the combination of some combination of this color. Like you see here, uh, when red and green color mixes, it gives a yellow color. Red and blue joins, and some combination of that, it gives a magenta color, and the blue and green color gives a cyan color. And if there is a equal amount of red, green, and blue color, it gives us a white color. So this is the concept of color composite. It is a true color composite of another area, wherein we can see some water body here, hilly areas, and some habitation here. This is the image of the same area, but in a different color composites. It is known as false color composite, and these are some other examples of false color composite in different band combination. Here, the band combination like RGB, which they are placed, then these band numbers are represented like this. It is 1 2 3 combination. It is a 5 3 1 combination, and this is a 5 4 3 combination for thematic mapper data. Now I will request Dr. Kakali Gogoi ma'am to discuss about the characteristics of digital images.
Thank you, sir. You see, this characteristics of digital image, this depends on the sensor characteristics, and the resolution is another characteristics of this digital image. So the term image resolution, this is applied to the digital images, to the image film images, and other types of images, and it describes the details that an image holds. So resolution can be broadly defined as the ability of a remote sensor to capture and display details of the ground features, and this image resolution can be measured in various ways like spatial, spectral, radiometric, and temporal. So let us see what are these types are. Coming to the spatial resolution, you see there are different definitions of spatial resolution, but in general and in practical sense, it can be referred to as size of each pixel. So it is commonly measured in units of distance like centimeter or meter, or in other words we can say that spatial resolution is a measure of the sensor's ability to capture the closely spaced objects on the ground and their discriminations as separate objects. So this here you can see in this images, the images is are taken from 1 kilometer till 1 meter, and here in this series of photographs, the photographs taken from 1 kilometer shows lesser detail as compared to 1 meter. So in this is about the spatial resolution. Now coming to spectral resolution, you see we identify the objects in an image based on the spectral signatures. We saw the spectral excuse me, we saw the spectral response of those objects in different wavelength of electromagnetic spectrum. So sensors are designed to capture this unique spectral signature on the object, and here in this diagram we see the spectral signature of vegetation, which shows reflection and absorption in different wavelengths due to chlorophyll and moisture content. Another resolution is the spectral resolution. So this spectral resolution, this refers to spectral bandwidth and location in the electromagnetic spectrum. And in this figure, you see this vertical lines, they are the bandwidth, which means the spectral resolution of the sensor. And some lines are here, you can see in this figure, some lines are finer and others are thicker. This means the finer the spectral resolution, the narrower the wavelength range for a particular band. And you see this multispectral data, they have coarser spectral resolution, whereas this hyperspectral data, they have narrow contiguous bands. The next type of resolution is the radiometric resolution. Here the information content in an image is determined by number of digital levels that are used to express the data collected by the sensor. So, you see a definite number of discrete quantization levels are used to record, or we can say to digitize the intensity of the flow of radiation. And here in this photograph, or you can see the smallest changes in intensity level that can be detected by sensing these systems. And from this clarity in 8 bit and in 1 bit, you can see this is regarding the digital number of digital levels. Another resolution is the temporal resolution. You see here for example, to monitor the agricultural activity, image interval of 10 days may be required. So this interval of 1 year would be used, or we collect to monitor the urban growth. So here this to revisit any area, this temporal resolution is used. And likewise, this is in brief about the resolutions. Now let us just quickly go through the digital image processing. Professor Desmukh will discuss about the digital image processing.
Thank you. Learners, when we talk about digital image, and as madam has mentioned, that information about various objects of various themes are present in the image. However, this information lie hidden in the image, and that needs to be extracted by an image analyst. Now, the extraction of information from these images may be done in the visual mode, or using the computers. So this may be categorized as either visual interpretation or digital image interpretation. So although these two methods have their own distinct advantages, however, due to the advantages that is offered by digital image processing, the digital image processing are used for extracting information. And this digital image processing is a term which can be defined as where the digital images are processed using a computer, where the data is in digital form. So friends, in this session we have learned about what an image is, what a digital image is. We have learned about the different types of digital images, and also we saw about characteristics of digital images, particularly in terms of spatial, spectral, radiometric and temporal resolution. So thank you.
Do you wish to be part of a television studio like this, or any other media system, or already part of any media system, want to enhance a new set of skills? Welcome to School of Journalism and New Media Studies. Here in the School of Journalism and New Media Studies, we are offering program for all set of people to learn and enhance their media skills. The vision of School of Journalism and New Media Studies is to generate a new set of professionals in the area of media and communication studies with understanding about role of media in the national development and global understanding. We offer innovative programs in the field of journalism and mass communication that sets the benchmark of high quality learning and teaching process at the national level. We offer these programs across the country with the help of our regional network as well as study center. Same manner, many of our programs are offered through online mode with a sophisticated learning management system. SOGNMS offers programs from PhD in journalism and mass communication till certificate level. We have masters in journalism and mass communication. The eligibility is bachelor's degree, and we are introducing this program in 3 languages: Hindi, Tamil and English. Students from national and international students can join either through online mode as well as in the distance mode. We have 4 postgraduate diploma programs, specialized areas in the field of development communication, digital media, electronic media and journalism and mass communication program. And all these 4 programs are available in distance mode. 2 programs are available in online mode, development communication and digital media. And we have specialized certificate program in community radio. IGNOU employs various media and communication tools for better teaching and learning process. School of Journalism and New Media Studies utilizes this media system for delivering all our programs. Come and join with us for exploring a new career and enhance your media skills.
Are you a fresh graduate? Do you want to fulfill your educational aspiration by pursuing higher education in various interdisciplinary and multidisciplinary areas like environmental science, environment and occupational health, philosophy, sustainability science, folklore and culture studies? If yes, the School of Interdisciplinary and Transdisciplinary Studies offers various programs like master's program, graduate program, postgraduate diploma, certificate and appreciation program. The school offers 5 master's program: Master of Science, Environmental Science. The eligibility criteria for MSc Environmental Science is graduate in science, BTech, BE, agriculture graduate, forestry graduate and veterinary graduate.
Namaskar. Hello viewers and learners. Welcome to this session of Gyan Darshan. Today we have an expert, a resource person, Dr. Nisha Varghese, who is from School of Extension and Development Studies. Today she is going to talk about poverty. This is a course and this is a part of MADVS, PGDDVS, PGCSR and MACSR. This is a unit which is comprising of the topic on poverty, and it is part of this particular programs, which are MADVS, PGDDVS, PGCSR and MACSR. Welcome, Dr. Nisha.
Thank
It
you,
is
Dr.
very
Grace.
nice to have you with us. Let me start this session right away, Dr. Nisha. Let me ask you, pertaining to the topic, what is poverty line, and how do you define poverty in India as well as in other countries?
Right. Poverty is actually a state of not having enough material possessions or income with a person to meet his or her basic needs. By basic needs, we mean here food, water, clothing, shelter, education, and healthcare. Now, coming to what is a poverty line. Poverty line is the income required to purchase these essential goods, which I just now mentioned. That is food, water, clothing, shelter, electricity, education, and healthcare. So, the income required to purchase these essential goods is exactly the poverty line. Determination of poverty line is done using the cost of basic needs approach, in which the cost of a basket of all the foods that will meet the nutritional requirements of a person is calculated, and then it is also adjusted for the non-food requirements, the money needed for non-food items. So, in financial year 2021, around 12.3% of the population in India lived below poverty line. Now, there is something called the international poverty line. International poverty line is defined as a person living below US dollar 1.90. Any person who lives below US dollar 1.90 per day is at 2011 international prices is called poor. So, as per the international poverty line, in the financial year 2020-21, around 12.3% of the population in India was poor. In 1990, around 36% of the people across the globe were poor as per the international poverty line standards, which reduced to 9.2% as of now. The World Bank estimates that by 2021, because of the COVID situation that is going on, around 150 million people will be pushed below poverty line.
Okay.
In India, the poverty line is measured by the National Sample Survey Organization. And India, the determinant of poverty line is used, as I said, using the basic needs approach. In 1979, a task force was formed which defined poverty line as the expenditure for buying food worth 2,400 calories in rural areas and 2,100 calories in urban areas. Because in rural areas, people need to do more of physical labor. So, the calorie accounted for poverty line in the rural areas is much more than the calorie accounted for poverty line in the urban areas. Now, in 2011, the Suresh Tendulkar Committee used monthly expense on food, education, health, electricity, and transport to define poverty line. According to this, a person who spends less than 27.2 rupees in rural areas and less than 33.3 rupees in urban areas per day is defined as poor. Okay, so this means that for a family of 5, any family which spends less than rupees 4,080 in the rural areas and less than rupees 5,000 in the urban areas is considered as poor. This is as per the Suresh Tendulkar Committee. Then there was an objection to it that the poverty line defined is very low. Like no one can meet their daily requirements at such low levels. So the Rangarajan panel was formed, and they defined poverty line as less than rupees 32 in rural areas and less than rupees 47 per day in urban areas. So according to the Rangarajan panel, any person who consumes less than rupees 32 per day in rural areas and less than rupees 47 per day in urban areas is considered as poor. So, as per these estimates, 29.5% of India's population was poor in 2011-12. Now, coming to how poverty is measured in different countries. In Europe, any family with less than 60% of median net disposable income is considered as poor. Any person with less than 60% of median net disposable income is considered as poor, which means net disposable income means after deducting the taxes, the average income after deducting the taxes. So that is median net disposable income. In US, what they do is they calculate a threshold income by taking into account the basic cost of food for a family, and they multiply it by 3. So this is the threshold income. Any family which lives on an income below this threshold income is considered as poor. So this is how they define poverty line in US. In India, we consider the family expenditure on essential goods in order to account for our poverty line. Whereas in least developed countries, again, the consumption expenditure is used to define poverty line. So this is about what is poverty, how poverty line is defined in different regions of the world.
This has been very interesting. When we talk about poverty and poverty line, according to the data that you have discussed, in 2011-12, the poverty line was 29.5%, and now in 2021 financial year, the poverty line is around 12.3%, if I'm not wrong.
Yeah, the percentage of poor below poverty
line. So, which means our country, India, has made a good progress in terms of, rising of people above poverty. Right. So, the government is doing a lot of good work, which can be seen from what data has been presented. Thank you so much for this very informative insight. Dr. Nishad, my next question, after talking about poverty line and how it is defined, can you please discuss what is multidimensional poverty index? What do you mean by it?
Yeah, multidimensional poverty index was developed by Oxford Poverty and Human Development Initiative. So this is an index in which acute multidimensional poverty is calculated. It has 3 dimensions. It takes into consideration 3 dimensions. One is health, the second one is education, and the third one is standard of living. So there are a total of 10 indicators which are considered in these 3 dimensions. And poor households are identified using these 10 indicators, and an aggregate measure is constructed using all these 10 indicators. So let us look at what are these indicators under each of the dimensions. Under the dimension of education, the indicators used are, first one is years of schooling. Okay. Now any household is considered to be deprived if no household member has completed 5 years of schooling. The second indicator is child enrollment. Any household is considered to be deprived if any school-age child is not attending school in the years of 1 to 8. Okay. Now let us come to the second dimension, that is health. In health, again, there are 2 indicators. The first indicator is child mortality. Any household is considered to be deprived if there has been a death of a child in that household. Then coming to nutrition. Any household is considered to be deprived where any adult or child has malnutrition. If you have the nutritional data about them, if any of the adult or child is malnourished, then that household is considered to be deprived in nutrition. The third one is third dimension is standard of living. In standard of living, they consider different indicators. First one is electricity. Any household is considered to be deprived if the household has no electricity, no access to electricity. Then, in the same way, the second one is drinking water. Any household is considered to be deprived if the household does not have access to clean drinking water, or clean water is more than 30 minutes of walk from their house, then that household is considered to be deprived. The next one is sanitation. Any household is considered to be deprived if there is a lack of proper improved toilet in that for that particular household. Then flooring. If any household has a floor of dirt or sand, or the kacha floors that you call, then that household is considered to be deprived. Then you have the cooking fuel. If a household uses the fuel like wood, charcoal or cow dung, then that household is considered to be deprived. Then comes deprivation in assets. Any household is considered to be deprived if it does not own more than one or more than one of any of these assets, that is radio, TV, telephone, bike, motorbike, car or tractor. Any one of them, if they don't have even any one of them, then they are considered to be deprived in assets. So these were the three dimensions of multidimensional poverty index: education, health and standard of living. There are 2 indicators in education, there are 2 indicators in health, and there are around 6 indicators in standard of living, this which makes a total of 10 indicators. Yeah, that's about multidimensional poverty index.
This has been very well explained. With regard to multidimensional poverty, Dr. Nisha, when we talk about assets, education, health and education, that was the first indicator. Then you have health, and the third one was standard of living. In standard of living, I heard you discussing about the assets, that if they don't have one of these, like radio, television and telephone, do you agree that telephone now would be mobile phone in place of telephone? I think because of the the technology updation of technology, very few people would now use landline. Maybe instead of the asset being as telephone, it could be mobile phone.
Yeah.
It was just
it includes both any of those. Phone means any of those phones.
Yes.
Not necessarily landline. It could be a landline or mobile phone.
Very interesting. Another very interesting insight again. Now the next question, a very pertinent question, an important question with regard to poverty. What are the causes of poverty in India?
Yeah, there are several causes of poverty in India. As we all know, the first and foremost, always, whenever poverty is discussed, is about over-dependence on agriculture. Around 60% of our population is dependent on agriculture. And agriculture by itself has, as compared to the money that it generates, as compared to its contribution in the GDP, it contributes around 15.1% of the GDP, and it has 60% of the people working in it, which itself shows that the people in this sector are underemployed. There are 2 kinds of unemployment that happens in agriculture sector. One is disguised unemployment and the other one is seasonal unemployment. Disguised unemployment means they are not, they are not using exactly the amount of, productivity is low as compared to what they otherwise could have achieved. There are more number of people working on a piece of work than that is required.
Yes.
And the second one is seasonal unemployment. As we all know that agriculture is a seasonal occupation. When there is, at times there is a lot of demand for workers or laborers, and at times they do not have much of work to do. So over dependence on agriculture is one of the first and foremost reason for poverty. The second one is high illiteracy. the literacy rate has increased from around 12% to around 74% across the years. But still, India has the most number of illiterates in the country. So illiteracy, because when you are illiterate, you don't have the capacity to earn more, and naturally the people who are not they do not have the capacity, they are not capable, then that definitely their income will be less. Then the third cause of poverty is high unemployment rate. There is a lot of the unemployment rate is very high. There is a jobless economic growth. There is economic growth definitely in the country, but the employment opportunities are not rising in commensuration with the economic growth that is happening in the country. So this is another reason for or another cause of poverty in our country. Now, as we already discussed, there is a lot of disguised unemployment and seasonal unemployment which mars our country. Especially in agriculture, there is a lot of seasonal unemployment that the people face, and around 60%, as we said, are already dependent on agriculture. So, unemployment is also one of the reasons for poverty in the country. Then there is lack of entrepreneurship. The industrial base in India has remained very slender. The industrial sickness is very widespread, and the whole industrial sector suffers from capital deficiency. There is not enough capital to expand the industrial sector. So this is another important reason for poverty in India. Then we have a social system that is into play, which is another cause of poverty. The social subsystems are so strongly locked that the poor are incapable of overcoming their obstacles. Especially, our country has this strong and rigid caste system, in which the upper class though keeps progressing, the lower caste they don't find that much of opportunity to progress. Even in terms of education, they don't have that much of, though the government provides the opportunities, but the caste system is so strong that the society itself does not allow them to progress. So this is another reason for poverty in our country. The sixth one is lack of investment for development of poorer sections of the society. A lot of investment is needed in order to uplift the poor from poverty. Investment in education is needed so that they are educated enough, the required skills are developed, required training is provided so that they can come out of poverty. Similarly, investment is needed to set up new industries which can provide gainful employment to the people. So, lack of proper investment is another important reason for poverty. Then there are a lot of regional imbalances, like industries may come up in certain regions or certain parts of the country, whereas the other parts are still predominantly agrarian. Right. So this is another reason for poverty, the rise of poverty in our country.
If these are the causes of poverty, can you briefly explain what are the solutions, what are the remedies of poverty?
Yeah, let us look at some of the remedies of poverty. One of the important remedy of poverty is to increase the savings. When the savings are increased, these savings are plowed back as capital in the society. Right. So, saving is an important factor which can lead to which can be considered as one of the remedies of poverty. Second one is increase in investment. Again, investment and saving are also interlinked. The more the saving, more are the chances of investment. So increased amount of investment, and investment in all the sectors, not just investment in any particular sector, but investment in all the sectors. So that, because one sector will act as will create demand for the products of other sector. For example, when we invest in industries,
Right.
okay, for example, when we invest in agriculture, they will need agricultural implements.
Right.
So the demand for implements increases. Now this demand for implements, they will have to set up industries or factories for creating those implements,
Right.
for creating tractors, for manufacturing tractors, for manufacturing those implements, for manufacturing the drip irrigation, sprinkler irrigation. So investment in all the sectors across is needed in order to remove poverty. Then another one is balanced growth. When the investment is done in all the sectors, when all the sectors grow together, then this is called balanced growth. None of the sectors should be left behind. Again, another form of balanced growth is there should not be any regional imbalances. The growth should happen in all the regions simultaneously, so that people don't need to migrate away from their regions in search of jobs. Enough job opportunity should be there in that particular region itself. So balanced growth is another important factor that can is a remedy to poverty. Then human capital formation. As you know, India has a abundant resource in terms of human capital.
Right.
The only problem that mars the human capital of India is the lack of skill, the lack of knowledge, the lack of skill. So proper skill training, proper building up the capacity of the human capital is needed in order to lift the people out of poverty. Then another important remedy is industrialization. More industries come up, in a balanced way across the regions, the more people will be lifted out of poverty. So industrialization is another important remedy for poverty. Yeah, these were some of the remedies for poverty.
So when we talk about the solutions of poverty, the remedies for poverty, these are savings. You increase your savings, and then you increase your investment in all the sectors, as well as there should be balanced growth, balanced regional growth. For example, let's say some parts of India should not be left behind when it comes to investment or industrial growth. Right. And then you have mentioned about human capital. Dr. Nisha, I was just thinking, when we talk about human capital, if you increase the skills of of people, the human capital, if you increase the skill, then the people or the person who has better skill, he or she will be more productive. This productivity would lead to increase income. Increase income would lead to increased savings as well as increase investment. Right. So do you agree that these are all related?
Right.
A skill would lead to more productivity and more increase in income and more savings.
Absolutely. Skills will definitely lead to more income, more employment opportunities will be opening up in front of a skilled person. Again, there is a need to have a proper need assessment for what kinds of skill are in demand in the market. If we assess the needs, because there will be different kinds of skills that are or trained personnel that are needed in different regions. So once we identify the right kind of skills, if we have a proper need assessment study and identify the right kinds of skills in right kinds of different areas, then we will be able to train more and more people in those areas, and they will be able to find gainful employment opportunities. So that is how it will help in lifting them up out of poverty.
Thank you so much, Dr. Nisha, for giving giving us such informative insight on what is poverty line, dimensional poverty index, as well as the various problems caused by poverty, as well as the solutions to poverty. Thank you so much for sparing your time to be a part of Gyan Darshan today.
Thank you, Dr. Grace.
Thank you so much, viewers. I hope you were all listening to this program. Thank you.
We wear clothes on a daily basis. But have we ever wondered, where do our clothes come from? Who makes our clothing? And who are the people and the process responsible for the whole manufacturing of our clothing? If you want to know more about this, Indira Gandhi National Open University from the School of Continuing Education has launched a program which is Certificate in Apparel Merchandising. There are many benefits after doing this program. You can become a designer in various fields. It can be fashion designer, apparel designer, costume designer, or even a textile designer. One can also work as a fashion consultant. Research and development is another field which one can take up after doing this certificate course. Going into academics is another perk after doing this program. Getting into fashion houses or fashion studios as an intern is also a very good option post doing the certificate in apparel merchandising. The basic eligibility of the program is 10+2. The duration of the program is 6 months to 2 years. The program is also available for both the admission cycles, which is July and January. The exams are conducted twice a year, in June and December. So what are you waiting for? Join this program and get an enriching knowledge in the field of apparel merchandising. And to do so, you can log on to the official website of the university, www.ignou.ac.in.
Dear learners, welcome to this teleconferencing session, the topic of which is geological work of rivers. Learners, we know that India is characterized with beautiful landscapes. If you see from north to south or east to west, in the north, in the Himalayan mountainous region, we see glacial landscapes. Coming towards little south in the central India, we see large alluvial plains, Indo-Gangetic plains. In the west, we see the desertic landscapes, and if we come towards little south further, we see Deccan traps, Deccan plateau in some parts, and then further south in the both east and west coast regions we have Western Ghats and Eastern Ghats, and further on the coastal regions we see beautiful coastal landscapes, including the beautiful atolls in the Lakshadweep and the coral reefs in the Andaman Nicobar Islands. Further in the east, we see a large delta, that is Sundarban Delta. So, friends, we know that these landscapes are developed by different kinds of geomorphic agents, and the topic of today's session is about the geological work of rivers. So, we know that, as you see in this slide, that various kinds of erosional and the depositional processes of rivers, they give rise to, or they produce various kinds of landforms. And here in this session, we are going to focus on this erosional and depositional processes. So this session, in the beginning, we are going to discuss about geomorphic processes and its types and the agents, and then we'll go on to discuss about geomorphic cycle and the fluvial cycle of erosion. Then we'll discuss in some detail about the fluvial erosion and its types, processes, and the factors which affect the fluvial erosion. And at the end, we will touch upon the sediment transportation and deposition process. So now let us begin with this. We know that geomorphic processes this continuously operate on the Earth's surface, and this processes by their working they bring about large changes on the Earth's surface, and thus they create beautiful landscapes on our Earth's surface. This geomorphic processes can be categorized into two. It is called as exogenic or exogenetic or external processes. These processes operate on the Earth's crust or near the Earth's surface, like weathering, erosion, transportation, and deposition of the materials which has been eroded. The second type is endogenic or endogenetic, or it is also known as internal processes, which operate within the Earth, and major changes are brought about on the Earth's surface and by earthquakes and volcanic activities, which are again governed by plate tectonics theory. Now, these processes continuously operate on the Earth's surface, and there are various agents like say rivers, wind, glaciers, underground water, and seas. These geological agents are able to change the surface of our planet, and these agents derive their energy from sun, Earth's gravity, and climatic parameters. Now, the functions which are carried out by these processes are weathering, which is a process of disintegration of rocks, and erosion, which is a process of breaking down or disintegration of rocks due to the physical forces associated with the natural agencies, and which is followed by removal of the dislodged rock fragments and the particles away from the site of their weathering. So, the difference between weathering and erosion is that weathering includes only the disintegration or the breaking down of the rocks, whereas the process of erosion includes the process of weathering as well as the transportation. And transportation is the process of removal of dislodged and disengaged materials from the site of their formation by various agents, and deposition is the process of accumulation and dropping down of these transported materials due to the loss of the capacity of that agent, which cannot hold the load further. Let us now come to the geomorphic cycle. Geomorphic cycle, or the cycle of erosion of landform development, or also known as the deviation cycle. It refers to time during which an uplifted landmass undergoes alteration through the land sculpture plane or peneplain process. This figure shows the fluvial geomorphic cycle, which is depicted into 4 stages, that are initial, which is at the right side, then where the rivers originate, and this is generally the area of higher elevation, then the young stage and the mature stage, and this is the old stage. And you can see here that young and the initial stages are characterized with high elevation, whereas the mature stage and some part of the old stage, where this is the moderate stage, and the old stage is the gentle stage. Now let us now discuss about these 4 stages in some detail here. The first stage of a fluvial cycle is initial stage. In this stage, the river water follows along the interconnected depressions on the surface of the earth, and since this is at the higher elevation, the gradient is very high, and the streams are turbulent. And the second stage is the young stage. Now the young stage is characterized by a typical V-shaped valley, because there is a high elevation, and that leads to stream lengthening by headward erosion, and that causes them to grow longer. And since the channel gradient is very steep, the youthful stage is characterized by rapid vertical erosion and valley deepening. A steep channel gradient increases the velocity further, and also the kinetic energy of the river flow, which increases the river's transporting capacity, and overall shape of the river valley is gorge and canyon type. The third stage is the mature stage. The earlier part of the maturity stage is characterized by significant lateral erosion as compared to the downcutting or the vertical erosion in the initial and the youthful stage. And this is also characterized by well integrated drainage network, and the amount of vertical erosion or the valley deepening is decreased as discussed in the mature stage, and the lateral erosion increases, and that causes expansion of the valleys, and that changes the V-shaped valley into a broad valley with uniform or rectilinear valley walls. And the significant reduction in the valley deepening is due to the major drop in the river channel gradients, flow velocity, and also due to the carrying capacity. Now the fourth stage is the old stage, and there is a lack of valley incision that characterizes this old stage, and like the mature stage, there is a vigorous lateral erosion and valley broadening in the old stage. In the case of old stage, the valley deepening is almost non-existent because there is a extremely low channel gradient, and also the kinetic energy is significantly lower. And learners, you may note here that the duration of the old stage is many times longer than that of the youth and the mature stage combined. Now this figure shows the cycle of erosion, which begins with the upliftment of a landmass for a brief period of time, and you see here this figure, here on the x-axis is the time, and on the y is the altitude. So this figure shows two curves here. The top one, the upper curve is the water divide summit, and the lower curve shows the valley floors and of the landmass, and the difference between these two curves is actually the is the initial relief or initial average relief, and here the A and C, this is A and this is C. This shows the maximum absolute relief. So as you see, with time, as the time goes, there is a change in the elevation of in the profile of the river. In the initial and the youth stage, there is a high elevation, and as it passes through different stages and reaches to the old stage, the elevation is reduced. Here in this figure, it again shows the same thing, and here you see the base level. This is the base level, the lower line. It is the base level that reflects the most significant vertical erosion or the vertical or the valley deepening, and as the uplift phase of the continent comes to an end at point C, here this is the C, sorry, this is the C, and the upliftment of the landmass comes to an end here. So this shows how with time the elevation changes for the entire stage of river. Now I'll request Dr. Kakari to discuss about the fluvial cycle of erosion.
Yes, sir. Like Professor Deshmukh, he have discussed about the initial stage, the youth stage, the mature stage, and the old stage. But what do you mean by fluvial cycle of erosion? You see in this slide, if you see, there are 4 stages: the initial stage, youth stage, mature stage, and the old stage. But the fluvial cycle of erosion, this refers to the progressive landscape changes which is caused by a river or stream that progresses, as you can see, from A to D, that progresses from an initial stage to an old stage. Thus, these stages of fluvial cycle of erosion, these are 4 stages as discussed, and at the initial stage, the river or the stream, this first begins, and as water flows into the lowest place from among the surrounding hills, this provides the waterway through an existing valley. So over a period of time, the river or the stream that erodes some of the steeper you see edges along its banks with more you can say with more noticeable erosion. So maybe during any flood events. Thus over a period of time, this widens the valley on either side of the river and smooths the land surface in the valley. So this is about the fluvial cycle of erosion. Coming to the next slide, if we discuss about this fluvial erosion, here you can see in this block diagram that and this fluvial or the river this geological work, this is done in 3 phases, which comprises of erosion, transportation and deposition mainly. So in this block diagram you can see the first stage is the weathering and erosion, which occurs where the river starts or from the hilly area, and in the course of its time you can see this transports with the land transports, and this deposition is done by geomorphic agents like water, ice, glaciers, etc., which is the next step, that is transportation and deposition. And over a period of time, these sediments, they are transported and they are buried, and this with lithification, this takes place after the sediments that have been deposited and buried, and they form sedimentary rock. So there are fluvial processes like we have erosional landforms, then we have depositional landforms. This is dependent upon the erosional process of the river, and the depositional process or the sediments that deposits due to which this depositional landforms occur. So the erosional landforms are nothing but the landforms that results from progressive removal of the bedrock mass. For example, you see various types of valleys like gorges and this canyons and even potholes, rapids, then waterfalls, terraces, then meanders. These are the erosional landforms. Then depositional landforms, they are the landforms that are shaped by you see deposition of different types of eroded materials, like for example, you see alluvial fans, cones, natural levees, flood plains, alluvial plains, terraces, deltas. These are the depositional landforms. So there are types of fluvial erosion. There are three types of fluvial erosion: the vertical erosion, lateral erosion, then headward erosion. So you see fluvial or fluvial erosion, this is defined as the removal of sediments from the surface of the stream channel, as we are discussing it. And the vertical erosion, this refers to the down cutting of river valley and thereafter deepening the valley by the river. Whereas in lateral erosion, you see this erosion takes place along the river banks. So the current of the stream that flows the outer side of the curves or bands in the channel, and the lateral erosion this takes place. So in lateral erosion and in subsequent valley, the valley becomes widen or widening and more active, and this is significant during the mature stage of the river development. But in vertical erosion, there is valley deepening. So the other type of fluvial erosion is the headward erosion. Headward erosion is nothing but the tendency of the stream channel to lengthen upslope as a result of greater erosion at valley headwards. One of the example is the river capture or river piracy. This occurs when the headward erosion breaches a drainage divide and intersects another channel and captures its flow. So these are the three types of fluvial erosion: the lateral erosion, vertical erosion, and the headward erosion. So here in this slide you can see here depicts stage 1 and stage 2, where you can see two rivers, river 1 and river 2. So a tributary of river 1 in stage 1, as you can see, where has the greater gradient and it carries out the headward erosion. So this after some time, when it reaches river 2 in the stage 1, then it diverts to river 1. As you can see in stage 2, it diverts to this river 1, and this happens because the gradient of river 1 is you see steeper, and maybe it overpowers the river 2, where river 2 maybe it's flowing slow. So here in stage 2 you can see the band where the diversion takes place. This is known as the elbow of capture, and the remaining part of river 2, here this becomes thin, and this is now beheaded river, and this beheaded river is termed as misfit. So this stages, this depicts the river capture, river piracy, and stream piracy. So now coming to the processes of fluvial erosion, there are you see two type of erosion. One is mechanical erosion, then chemical erosion. So mechanical erosion, this includes corrosion or abrasion, then hydraulic action and attrition. And in the chemical erosion, the corrosion or the solution and carbonation, these are been included. I will request Professor Deshmukh to further discuss about these processes of fluvial erosion in detail.
Thank you. So, as you had discussed about the fluvial erosion, let us now come to the further detailing of the types of this, the mechanism of this erosion. So, first we'll discuss is corrosion or the abrasion. So, it is a mechanical wear and tear of the rocks on the sides and floor of the river valley. So, this occurs through the impact of the erosional tools or rock particles like boulders, pebbles, cobbles, which are carried in the current of water and they strike against the exposed bedrock of the channel, and this erodes this erodes the materials there. The erosional mechanism of abrasion operates in two ways: vertical erosion and lateral erosion, as discussed by ma'am. Vertical erosion leads to erosion and deepening of valley floors, whereas the lateral erosion leads to erosion of the valley walls and widening of the valleys. The hydraulic action is due to the thrust of the water body itself. It enhances the mechanical loosening and removal of broken rocks through its water force. Attrition is the process in which there is a breaking away of the transported material by striking or the mutual impact with one another. And it is a mechanical tear and wear of the erosional tools within themselves. Like we discussed, these materials, the particles, when they move, they collide against each other, and they are fragmented into finer particles. Then coming to the corrosion or the solution, it is a chemical process of rock erosion, and we know that river water is capable of dissolving matter from mineral of a rock in the presence of some adding substances like alkali matter and the gases like carbon dioxide, which actually enhances this process of solution. And now coming to the factors which affect fluvial erosion, these are the volume of discharge and the velocity of the flow, character and size of the sediments, rock type and geological structures, infiltration capacity of the area that is drained by the river, vegetation, which also affects the stability and the permeability of soil. Now let us come to the sediment transportation. It is a natural phenomena through which river transfer the sediments to its downstreams due to the influence of gravity. And we can relate this with during the flood. We see that flood carries a lot of load of the materials which are generated from the land surface, and the river carries a load of this material in solution in addition to the visible sediments. Sediment transport is primarily mechanical, and solution transport is mainly chemical. And these are the various categories of stream load, like dissolved load and the solute load, then the suspended load. In the case of dissolved load, it consists of soluble ions that have entered the water, and suspended load, it composed of small and light solid particles like silt and clays. Then further there is the saltation load and the bait load. This is the material of intermediate size which are too heavy to be held in suspension and lighter than the bed load. And in the case of bed load, which the water carries the materials in its river bed, and these materials collide with each other and they erode the materials. Now coming to the last stage of this session, deposition is the process through which the sediment deposition takes place when there is a loss of energy of this transporting media. This transportation particle are no longer available, meaning that the energy is not available to transport this material further. So that is why the deposition takes place. Now let us summarize what we have learned in this session. We started with discussing about geomorphic processes, then we talked about geomorphic agents, then the fluvial cycle of erosion, and then the fluvial erosion, its types, fluvial erosion processes, and the factors that affects, and at the end we briefly discussed about the process of sediment transportation and deposition. So in in another session, we will discuss about the landforms which are produced by fluvial processes. Thank you.
Thank you.
Are you interested in television journalism or radio journalism or online journalism? Or do you want to learn with the flexibility of open learning? Or if you are a working professional, wants to enhance your knowledge and skill with certification in the field of electronic media, then School of Journalism and New Media Study IGNOU offers PG Diploma in Electronic Media for you. This program includes audio and audio-visual program production for radio, television and online platforms. Here are some important details about the program. We have total 8 courses of 32 credits, 6 theory courses, 1 practical and 1 project. Eligibility: bachelor's degree in any subject. Minimum duration 1 year, maximum 3 years. Medium is English, but students can write their examinations, assignments, practical and project in Hindi also. So if you are interested in television, radio or online media, please come and join IGNOU's PG Diploma in Electronic Media.
Welcome learners to another teleconferencing session. In this session, we will discuss about fluvial landforms. This session is based on the BSc program of School of Sciences with the course codes are BGY CT 131, that is Physical and Structural Geology, that is the core course, and it is also related to elective course BGY ET 147, Geomorphology and Geotectonic. So let's see the outline of today's session. Today we will be discussing about drainage patterns. We will discuss about the types of river channels, and we will discuss about the erosional landforms and depositional landforms. So as we have discussed in one of the session about the processes of erosional processes, and in this session we will focus mainly on erosional landforms and depositional landforms. So let us begin with the what do we mean by drainage patterns. So drainage patterns are nothing but they are the spatial arrangement and form of drainage system in terms of geometric shapes in the areas of, you see, different rock types, different geological structure, then climatic conditions, and denudational history. And this drainage patterns, they indicate the influence of initial slope, variations in rock hardness, structural controls, then recent diastropism, and the drainage basins recent geomorphic and geologic history. So drainage patterns, they are essential in interpreting geomorphic features because you see various variables regulate them. So there are many this drainage patterns. So here in this slide you can see two figures. One is dendritic and another one is radial. What is dendritic pattern? As you see, this dendritic, they are just like the branches of a tree. So this is also termed as branch like pattern, and this is one of the most common type of drainage pattern, and they are distinguished by as you can see in this figure, they are having uneven branching of tributary streams in various directions. Generally these directions are less than 90-degree, and this emerge on homogeneous resistant rocks, which indicates a total absence of structural control. The another pattern is the radial pattern, and we also call it as centrifugal pattern, because as you can see in this figure, the streams radially diverge from the center to the high places. So this structure is frequently seen in the sides of domes. And this, as you can see, as this figure clearly depicts, that the streams emerges at the relief center, this center point, and this flows down the mountain in all the direction. The next pattern of drainage is the parallel pattern. Here in this figure you can see all the streams are almost parallel to each other. So here this parallel pattern, this occurs in the areas with steep slope or where there is structural controls, and this is a characteristic feature of ridge and valley topography. So the another pattern is rectangular pattern. Here the streams you see in figure E, this is in rectangular shape, and here the main stream and its tributaries, they have right angled bands. So this typically these bands are occurs where there are joints and falls, and they meet at 90-degree angle. Then there is another type of drainage pattern we call as trellis pattern. Here in figure C you can see this is the trellis pattern, where the streams generally they flow the regional slope and are well adjusted to any geological features, and they are prominent in folded and faulted area where the stream erosion has truncated alternating weak and strong strata. So this is the trellis structure or pattern. And the next is the centripetal pattern. Here you see this is just opposite of centrifugal pattern that I have discussed, that is the radial pattern, and this is centripetal pattern, where this there is a converge into a central depression. As you can see this arrow marks here, this is a depression. This is formed by several streams that emerge from the surrounding, then uplands, and converge in centrally lowland, and it might be a depression, it might be a basin, or a crater lake. So these are the drainage patterns. Now if we talk about this type of river channels, we all know that river channels, it can be a straight channel, it can be a meandering channel, or it can be an braided channel. So this you see in this figure we have given three channels. One is straight, meandering and braided. This straight channel is very rare, and they are usually found where there is same structure and parallel disposition of hard and soft rocks on the underlying topography. But you see this straight channel is rare, and in the middle here you can see the meandering channel. We all know that a river is free to flow, or it travels freely across a valley floor, and when it flows, they develop most readily on low gradient. The slopes composed of you see they are easily eroded by sediment, and they freely flow, and that gives a shape of a meander, and these are known as meandering channels. Next is the braided channel, where these channels they form like a braid of hairs, where the sand and this sands are filled, and they give the form of hair braid. And here you can see the stream divides into branching, and and they form sub channels which are separated by islands and sandbars. These are the three types of river channels. Now further let us discuss about erosional landforms. I will request Professor Deshmukh to kindly discuss on the erosional landforms.
Thank you. In one of the session, we discussed about various kinds of fluvial processes, and also in that we discussed about the four stages of river. Those stages are initial, youth, mature, and old stages. And we studied that in the initial and the young stage, particularly. There is a valley which has a typical V shape. So we will discuss about this river valley in some detail here. If you see this figure here, the river valleys is one kind of erosional landforms which are the shape and dimension of the fluvially originated valley change with as the river advances in different stages during its cycle of erosion. And if you see the cross-sectional profile of the river valley, it is typically V shape. And as the river goes into from the youthful stage to the mature and the old stage, the typical V shape valley it becomes much wider at old stage. In this figure, if you see, this is example of a river in the West Siang district in the Arunachal Pradesh. Gorges and the canyons are the very deep and the narrow valleys which have very steep valley side slopes, and when this becomes much larger, it is known as canyons. Typically, a typical example of canyons are the Grand Canyon, which has been developed by Colorado River in Arizona of the United States of America, and this is a view of the Grand Canyon, of a part of that. And India also has in some rivers that show some canyons. Second is the waterfalls. It is again another landform which is developed due to the sudden descent or abrupt break in the longitudinal course of rivers due to several factors like variation in the relative resistance of rocks, or the difference in the topography, relief, or fall in the sea level, and also due to earth movement. Now you see in the right side that this is figure that shows a photograph of a waterfall. You see in the Vindhyachal mountains, these rocks are basically the horizontally bedded rocks, and here you see that this is the river flowing from the top, and after that there is a sudden break in the topography and the water falls here, and this forms a waterfall. Then many of you must have seen in the river beds there are some small depressions, and these depressions are known as potholes, which are the kettle-like smooth rounded bowl of or cylindrical shaped depressions, and this is developed due to mechanical aberration and downcutting by rock fragments which are trapped in the whirling currents, and depth of a pothole is much higher compared to its diameter, and if there is a much larger depression, it is known as plunge pool. As you see in this figure, this is the flow of the water here, the river water here, and there may be some rock fragments, some pebbles or boulders, the cobbles, and they may be trapped in the river bed, and they are in the eddy currents, and which is again swelled by the currents, and due to its movement, there is the process, it grinds the river bed, and it creates a small hollow, and with the time this may become much larger. Then another landform is the plunge pools, which is produced on the river bed, mostly because of the hydraulic action, where the water falls from some height and causes bedrock erosion. As you see in this figure, this is a river which is flowing here, and it again there is a break in the topography, and it from the height the water falls, and because of that there is a erosion of this material, the softer rocks, and this causes development of a plunge pool. So this is produced where the water is filled up at the base of the waterfall. Another important landform created by these processes are the river terraces, which are narrow flat surfaces on either side of the valley floor and are known as river terraces. It represents the level of the former valley floors and are the remnants of the older flood plains, and these are formed due to dissection of the fluvial sediments of the flood plains which have been deposited along a valley floor. Now we can categorize river terraces in different types. The commonly we can categorize into two types. One is paired terraces, and the second is the unpaired terraces. Paired terraces are formed due to the rapid vertical erosion resulting in the occurrence of terraces on both sides of the river beds. As you see in this figure, these are the river terraces, and you can see these are present in the both sides of this river valley. Whereas in the case of unpaired terraces, you don't see such pairing of these terraces, and there is no pairing here, and such unpaired terraces are formed due to simultaneous vertical as well as lateral movements of the channel. So this results in the valley deepening and also lateral erosion. The formation of terrace are caused by either crustal movement, which is particularly tectonic, and isostatic movements, as it can trigger downcutting if there is upliftment, and the downcutting may be triggered. In the case of eustatic sea level variation, it also cause the formation of terraces. In the case of constant sea levels, it encourages lateral erosion and valley expansion, whereas the rising sea levels may trigger shifting processes. Further, the climatic changes may also cause development of river terraces, as we know that there is even in a slight variation in various climatic variables like in precipitation, this may result in significant change in the plant cover and sediment delivery to streams, and that may in turn determine or govern formation of a terrace. Stream capture, it is a unique situation when the upper reach of a low-lying stream captures a stream with a higher base level, then the captured stream gains a new lower base level, and again then the stream erosion takes place. So this then the new level it falls on the valley floor. Now we'll discuss about the depositional landforms. I'll request my colleague Dr. Kakali Gogoi to discuss about the depositional landforms.
Yes, as you learners, you have heard about the erosional landforms that he have talked about: river valleys, gorges, canyons, then potholes. There are also some depositional landforms, here in this figure you can see this is an alluvial fan and cones. Here this occurs when when a river this abruptly falls from a hill or from a mountain on a plain, and this deposition takes place at the base of the foothills. As here you can see in this figure, this is the alluvial fan, and this thickens in the this thicknesses of the fan and the cone is maximum at the places of deposition as it widens, and it thins out at greater distances. And this name the name is regarding because it resembles the fan and the cones. And in the next figure you can see here these alluvial fans they develop when the slope of a hill or mountain, the front is here the mountain front is gentle and the amount of water is greater than the amount of debris. As you can see here, causing the debris to spread out, and this form an accurate shape. And here in this sketch you can see this is the mountainous area, and this steam comes out from the mountainous, this is the mountainous steam. And here in the alluvial fan there are distributary channels, and this side is known as the flat valley floor. This is regarding the alluvial fan. And another type of landform is the braided river. As mentioned earlier also, this braided rivers that resembles the pattern of the braids of the hair. So this channels which is you see in this this have a network of channels, and this resembles the braids of hair. And likewise a braided stream, this also has an intricate network of this dividing and rejoining channels that separates from one another by sands and gravel burrs. And if we view from above the channels, they resemble the complex strands of this braid. And this is an example of this alluvial terraces. This is a part of the river Brahmaputra. So this is about the braided rivers. Another landform is the meander deposits. You see the channels of meandering the streams, they are semicircular in cross section. As you can see in this figure, this meandering rivers, this photograph show the meandering rivers. They are this river migrating from the floodplains of this is the river Brahmaputra. This meandering river, it shows a typical zigzag path, so this is known as meandering. Then another this landform is the oxbow lake. We can see in the next slide. These oxbow lakes are nothing but they are formed due to the faster erosion on the concave banks. And this deposits, as you can see in the lower part, here this is the main channel in the right hand side, and this is the oxbow lake. And the deposits that occur here in the this oxbow lake, you can see this is the point bar. So these are about this landforms, this oxbow lake. Another one is the next slide. You can see this is the floodplains and the alluvial deposits. So floodplains, here you can see the river channels when they periodically receive more water than they can accommodate. or they overflow to their banks and they spread across the adjacent low lying areas, which results to a floodplain. And the finer materials, they are deposited, the finer materials they are deposited and they give rise to a thick deposits. They are known as the alluvial deposits. In the next slide you can see the same. Here this is the meandering river with oxbow lake. Then you can see the flood plains. Here the natural levees, they are the embankments formed naturally after a river flood and recedes, and this friction with the floodplain during the flood cause a decrease in the velocity of the river, which leads to the deposition of the material, and the flood water is this carry this deposits. So in the next slide you can see this is a cross section showing the floodplain with the river and levee, and lower in the lower slide this is the floodplain where you can see the this mud cracks. So we have some in this floodplains can be of many types, which I will request Professor Desmukh to discuss about the types of the floodplains.
Thank you. As you discussed about the formation of floodplains, now we'll discuss about the types of floodplains. So basically, there are two types of floodplains, which are convex and the flat. This convex kinds of floodplains is shown by most of the large rivers like Mississippi, Amazon, and Nile. These floodplains are wide and have somewhat convex cross sections, where the ground slopes away from the river bank to the valley sides. And the second type is the flat floodplains, which is shown by most of the medium-sized rivers, and it is created by mainly through the process of lateral accretion, meaning that it is the process of sedimentation on the inside of meander bends, and it may also occur as a result of alluviation in braided rivers. Now this is a prominent landform in the eastern coast of India. It is delta, which is a nearly flat triangular or fan shaped plain at the mouth of the river that resembles Greek letter delta. So here this is the area showing delta, and based on the processes which are active on this delta, it can be characterized either as stream dominated, wave dominated, or the tide dominated. In the case of stream dominated deltas, the stream processes are dominant. In the case of wave dominated deltas, the wave processes are dominated, and in the case of tide dominated deltas, the tidal processes are dominated, and these deltas are continuously modified into tidal sand bodies, which are parallel to the direction of the tidal flows. And this is again a plan view of a delta, showing its triangular shape and its distributary channels and the lagoon. This is the cross section of a delta, wherein you can see the top side beds, foreside beds, and also the bottom side beds here. And this is the profile of the river. We can have two kinds of profile. Rivers show two kinds of profile: the longitudinal or long profile, and also the transverse profile. And longitudinal profiles are the gradient of the water surface from the source to the mouth. As you can see in this figure, on the x is the distance from source and the y is the height, and this is how the profile of the river is shown here. At times it is smooth, and sometimes it may show some break in that slope of the profile. And this point where there is a sudden break in the profile, it is known as nick points, which may be represented either as a topographic break in the river course. This is the transverse profile, which is actually a cross section of a river valley at some point, wherein you can see the valley slides and the channel here. And in another case, when there is a balance between the carrying capacity of the river and the total load to be transported, then in that case the river shows this kind of profile, and this profile is known as a graded profile. So the river's long profile or longitudinal profile becomes a profile of equilibrium when there is a balance in that. Learners, we have discussed about various kinds of landforms developed by fluvial processes in this session. Particularly, we started with discussing about different kinds of drainage patterns. Then we discussed about different kinds of river channels, and then we saw what are the typical erosional landforms developed by fluvial processes like V-shaped valley, gorges, and canyons. And then we saw different stages of land, different types of landforms developed at different stages of the river, and at the end we discussed about depositional landforms like floodplains, natural levees, and delta, the prominent landforms. And we at the last we saw about different kinds of profile. So friends, we will discuss about some other kinds of landforms in some other session. So with this we take your leave. Thank you.
Thank you.